Why do energies tend to move and move away from each other, unlike gravitational attraction and nuclear force? Energy, unlike gravity and nuclear forces, tends to move away from each other and be in motion. This is because the nature of energy is different from the essence of these two forces. Gravity is the force that attracts objects to each other, while nuclear forces are the forces that attract protons and neutrons to each other. Both of these forces depend on the mass or charge of the objects they act on. Energy, on the other hand, is unrelated to mass or charge. Energy can exist in various forms, such as the kinetic energy of an object, potential energy due to its position, or thermal energy, among others. Therefore, energy can act on different objects independently. For example, light exists in the form of electromagnetic waves. Light can act on all objects regardless of gravity or nuclear forces. The tendency of energy to move away from each other and be in motion can be explained by the following reasons. Conservation of energy. Energy can neither be created nor destroyed, it can only change forms. Therefore, energy must always be in motion and change its form. Increase in entropy. The overall entropy of the universe always increases. Entropy is a measure of disorder. Therefore, energy tends to move towards a more disordered state. Due to these reasons, energy tends to move away from each other and be in motion, unlike gravity and nuclear forces. To provide a specific example, light exists as energy in the form of electromagnetic waves. Light can act on all objects independently of gravity or nuclear forces. Therefore, light can freely travel between stars and planets without being attracted by gravity. Additionally, heat is a form of energy. Heat moves from hot objects to cold objects. This is because heat naturally tends to move towards the lower temperature object due to the greater disorder associated with higher temperature. We can easily observe these phenomena in our everyday lives. For instance, hot water cools down because heat moves to the colder air. Moreover, light passes through glass windows without being pulled by gravity. Assuming an empty space in the universe, it remains there no matter how hard a human struggles, but what is the source of the force that separates any object or moves it in the opposite direction when energy is released? In the empty space of the universe, assuming that humans are in motion, they will remain in the same place. However, if they separate from an object they were holding or release energy, the source of the force that moves them in the opposite direction is inertia. Inertia is the property of an object to maintain its state of rest or constant velocity when no external forces act on it. Therefore, when an object is separated or energy is expelled, that object experiences a force that attempts to move it in the opposite direction. This force can be explained by Newton's third law, which states, for every action, there is an equal and opposite reaction. Hence, when an object is separated, the force that separates it and the force that tries to move the object in the opposite direction are equal in magnitude but opposite in direction. To provide a specific example, when a person lets go of an object they were holding in their hand, the object falls downward. This is because the moment the person releases the object, the force exerted by the person's hand on the object disappears, causing the object to change from a state of rest to a state of motion. At this point, the object experiences a force in the direction of falling. Similarly, when a rocket is launched, the rocket's fuel is burned, and as a result, exhaust is expelled in the opposite direction. The rocket experiences a force that attempts to move it forward. Consequently, the rocket moves forward. These phenomena are easily observable in our daily lives. For instance, when you throw a ball, the ball flies in the direction opposite to the one in which it was released from your hand. Also, when a car accelerates, it tends to slide backward. All of these phenomena can be explained by the principle of inertia.